Hello friends, I am Jayesh Gandhi. Welcome to this series of tutorials on digital electronics. Today we are going to talk about the basic logic gates. So let us start our discussion with what do we understand by logic gates. Logic gates are electronic circuits that act as building blocks of digital electronics. Logic gates perform basic logic functions which replace the Boolean operators. By definition, a logic gate is an electronic circuit which has one or more than one input and only one output, whose value will be 1 only for certain combination of inputs. So we can imagine a logic gate as a black box which has got a number of inputs. So when you give these inputs, the output is generated and the output is 1 only for certain combination of input. Then this type of a circuit becomes a logic gate. Now going to more specific things, let us understand the first logic gate, and that is called the AND gate. This is the circuit symbol for AND gate. We can assume that we have got this circuit inside this gate. So A and B are replaced by two switches and Y output is replaced by the bulb. So when A and B are off, then there is no current in the circuit and therefore the bulb is off. So that is the first condition. If you go further and switch on the B, so I make this B on, keep the A off, then also the circuit is not complete and therefore the bulb is off. Similarly, in third case, if you take A is on and B is off, so this is on and this is off, then also the circuit is incomplete. There is no current and therefore the bulb is off. And finally, when both A and B they are on, then the bulb turns on. It will get the current from the switches and as a result the bulb will turn on. So that explains the logic table for the AND gate, which is equivalent to the AND operation in Boolean algebra. So if A is 0 and B is 0, Y output is 0. If A is 0 and B is 1, Y output is 0. If A is 1 and B is 0, Y output is 0. If A is 1 and B is 1, Y output is 1. Now when we talk about the logic gates, then the inputs 0 and 0 should be replaced by 0 volts as inputs, or for 1 it should be replaced by 5 volts as inputs. Similarly, for the output, when the output measured is 0 volts, then the output is 0, and when the output measured is 5 volts, then the output is 1. So that is how the AND gate is explained. Let us go to the next gate, and that is called the OR gate. It replaces the OR Boolean operation represented by the plus sign. The circuit we can imagine for OR gate looks something like this, where both the switches A and B are connected in parallel. So when both A and B are off, then there is no current in the circuit and the bulb is off. If we turn on B, then the current will flow through the B and the bulb will be turned on. If you make the status of switch A as on and B as off, then the current will flow through the A switch and the bulb will glow. And if you make both the switches on, then the current will flow and the bulb is on. So that is how you get for OR gate, when both the switches are off, the bulb is off, otherwise it is on. So the OR gate truth table looks like this. If 0 0, the output is 0, 0 1, the output is 1, 1 0, the output is 1, 1 1, the output is 1, 0 is 0 volts and 1 is 5 volts. So that is about the OR gate. The third function is the NOT function. It is the complement of a given bit. So if A is a binary digit and if you give it to the NOT gate, then the output Y will be complement of A, and that is, if A is 0, then the output Y is equal to A bar, and that is 1. If A is 1, then the output Y is complement of A, that is 0. So once again the voltage levels are 0 and 5 volts. So we have seen that the AND operator in Boolean algebra is replaced by the AND gate. The OR operator in Boolean algebra is replaced by the OR gate, and the NOT operator in Boolean algebra, or the complement operator, is replaced by the NOT gate. All the three circuit symbols we have seen and the truth tables we have understood. These three gates, AND, OR and NOT, they are called the basic logic gates because they act as the basic building blocks of digital electronics. With the help of these three gates, any digital circuit can be built. So that brings us to the end of this discussion on logic gates. I hope you have enjoyed the discussion. Please give a thumbs up if you like the discussion and subscribe our channel. Thank you very much.